Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now going to go through question number 5 from the International A-Level Pure Mathematics P4 Edexcel Specimen paper. And here we're told about figure 2, which shows the design for a logo of a fishing club. The design is made up of a shaded region R inside a circle of radius 3. The region R is the area between the x-axis and the curve, as shown in figure 3. Okay, so between the x-axis and the curve. The curve C is defined by parametric equations x equals 4 sine squared t and y equals 3 sine t, and t is between 0 and pi over 3. We've first got to prove that sine 3t is equal to 3t minus 4 sine cubed t. Okay, so here we have to first of all just deal with this identity and prove this identity. And then I think part B will be dealing with the actual question itself. So first of all now, let's prove this identity. Now to prove this identity, what we need to do, this is actually going back to P3 actually, but anyway, P3 can come up in P4 of course, as can P1 and P2. So here we have to try to prove this identity. So what I'm going to do is I'm going to use the compound angle formulae. Now the compound angle formulae are found in your formula book under P3, under the P3 section, and one of the formulas you'll see is the sine of A plus B equals the sine of A times the cosine of B, cosine of B, plus, if there's a plus here, there's a plus here for this one, plus the cosine of A times the sine of B. Okay, so just that's the compound angle formulae for sine A plus B. So what I'm going to do is I'm going to say that let's call sine 3t, let me call it sine 2t plus t. They're the same thing, right? So I can say that this is like my A and this is like my B when I'm thinking about that formula. So this is going to be the sine of A times the cosine of B, so sine of 2t times the cosine of t, plus, and then I have the cosine of 2t times the sine of t. Okay, now I want to end up with something with only sines in it. Now for sine 2t I don't have any choice. I mean, I don't want to have a double angle, I want to have single angles, so I can use the double angle formula for sine 2t. Now the double angle formula for sine 2t is basically, it's based upon this. So let me just call this, instead of sine A plus B, look, let's call it sine t plus t. That's the same as sine 2t, right? That's going to give me sine t times cosine t plus cosine t times sine t, and these two are the same thing. So that's 2 times sine t cosine t. So this is the double angle formula. So sine 2t is the same as 2 sine t cosine t. So I can write this as 2 sine t cosine t, and then I've got another cosine t that's there, plus, now I want to use the double angle formula for cosine 2t to change this into something that is a single angle. So there's another formula which is cosine of A plus B, which this is from the addition formulae or compound angle formula. This splits up into cosine A, cosine B, and then whatever's here is opposite sign minus sine A times sine B. That's how cosine A plus B splits up. So if I think about this, it's going to be so if I think of this as cosine t plus t, I'll end up with cosine t times cosine t minus sine t times sine t. I've called it A and B, both of them t. That's the same as cosine 2t. So we can say cosine of 2t is the same as cosine squared t minus sine squared t. Alright, so I can replace the cosine 2t with this, or I can go further on and simplify it more. Now I want everything in terms of sine here. So what I'm going to do is I'm going to change the cosine squared t into 1 minus 2 sine squared t and I have minus sine squared t. Sorry, what am I talking about? 1 minus sine cosine squared t is 1 minus sine squared t. Remember, very important identity, sine squared theta plus cosine squared theta equals 1. So cosine squared t is 1 minus sine squared t. So this is going to give you 1 minus 2 sine squared t. So cosine 2t can be replaced with 1 minus 2 sine squared t. So I'm going to have here 1 minus 2 sine squared t times sine t. Okay, I'll just keep this separate now. This is all of these things you should really know. Okay, you should really know this. So I mean, you can just replace the sine 2t with 2 sine t cosine t without showing these steps. You can replace the cosine 2t with 1 minus 2 sine squared t without showing these steps. Okay, it's not needed for you to show these steps, but I'm just showing you how to derive them if you forget them. Now, I'm ready to almost get there. So this is going to be 2 sine t cosine squared t plus, and then if I multiply this out, I'm going to get sine t minus 2 sine cubed t. Now, cosine squared t can be rewritten as 1 minus sine squared t, as we mentioned before. So this is 2 sine t times 1 minus sine squared t plus sine t minus 2 sine cubed t. So hopefully this will work out now. So this is going to give me 2 sine t minus 2 sine squared, or cubed t actually, because sine t times sine squared t is sine cubed t. Okay, plus sine t minus 2 sine cubed t, which will be the same as, so we can say cosine, or the sine of 3t, which we started with in the beginning, is equal to, you're going to have 3 sine t minus 4 sine cubed t. So there's the answer to part A of this question. Okay, so that's how we can write this out. As I said, all of these kind of proofs here, we don't really have to show them. If you can straight away quote that sine 2t is 2 sine t cosine t, and cosine t is 1 minus sine squared t, and so on. There's no need for us to actually show the steps. I'm just showing you in case you didn't know where they come from or you're not sure. Okay, so that's part A done, proving this identity. It's exactly as they asked us to show. Now for part B. Okay, part B says, using algebraic integration, find to 3SF the percentage of the circle that is shaded as part of the logo. So we need to first find the area of R and the area of the circle, where it's a radius 3 centimeters or 3 units, as we said. So the area of the circle, the area of the whole circle, is going to be pi times R squared, which is going to be 9 pi, because R is equal to 3. So that's the area of the circle, and we've got to find the area of the shaded part as a percentage of the area of the circle. Yeah, okay. So we need to find R, the shaded part. Okay, so we need to find the region R, the area of R, or the area R. We need to find the area R. So we need to basically find the integral of y with respect to x between the limits, okay, of 0 and 3. That's what we need to find. We need to integrate this function with respect to x between the limits of 0 and 3. But we have given this equation in parametric form. Okay, so for us to do this, we have to basically use this other parameter t. So I'm going to write, similar to substitution, dx dt dt. Okay, and now I have to change these limits in terms of t. So I'm going to call it right now t1 and t2. I have to change the limits in terms of t because I'm integrating with respect to t. So I know that y is 3 sine. Let's just replace everything with what we have. Okay, so I need to find dx dt. Let's find dx dt first. We know that x is equal to 4 sine squared t. So dx dt is equal to, now remember, this is the same as saying 4 times sine t all squared. That's what it means. So it's like dx dt is like 8 times the sine of t times the differential of sine t, which is cosine t. Okay, so dx dt is 8 sine t cosine t. All right, so that's what dx dt is. So let's write down everything that we have. Let's also change the limits now as well. We know that then we've got x equals 3 and x equals 0. And we know that we've got to find what t is. So we can say 4 sine squared t equals 3. So sine squared t equals 3 over 4. So sine t equals root 3 over 2. So sine t equals root 3 over 2. Okay, so we can say that t is equal to inverse sine of root 3 over 2. Okay, which is 60 degrees, pi over 3. Okay, so let me just work that out, make sure. Yeah, that's inverse sine of root 3 over 2. We have to deal in radians. Yes, it's in radian mode. Gives you pi over 3. That's right. So we got t equals pi over 3 as the top limit here. That's pi over 3 because we're doing it in terms of t. And when x equals 0, you're going to have sine squared t equals 0. So t is equal to 0 basically. So that's going to be, the bottom limit's going to be 0 here. Okay, so that's a 0. Now, what we can do here is we can start replacing everything. So we got pi over 3, and we got 0, and we got y. Y is basically given up here in terms of t as 3 sine 3t. 3 sine 3t, and we've got dx dt, which we know is times, you got 8 sine t cosine t, and we've got here dt. That's it. Okay, so we have to simplify this. All right, so first of all, sine 3t, we already were told that this is equal to this. Okay, so we already were asked to prove this. So we've already proved this part. So let's just replace sine 3t with 3 sine t minus 4 sine cubed t. So we're going to have the integral between 0 and pi over 3. You're going to have, let me take this 3 times, leave it for now. Let's leave it for now. This is going to be, let's take this 3 out. I'll take this 3 out and leave the 8 there for now. You're going to have, so sine 3t is 3 sine t minus 4 sine cubed t. And here we got 8 sine t cosine t and dt. Okay, now if I multiply these out, it will help me actually. Yes, so now I can see what to do. I will multiply that 3 by the 8. That's going to give me 24. 3 8s are 24. I'll have 0 and pi over 3. If I expand this bracket, I've already taken the 8 out, remember. I'm going to have 3 sine squared t times cosine t. Okay, that's when I multiply this by this. I've already taken the 8 outside. Okay, this 8's already gone outside. And then I'm going to have minus 4 sine to the power of 4t times cosine t dt. Now, this is something that is useful for me to use to integrate because I have something of the form of the function of x, okay, times its differential. Okay, so I have like the function of x, I've got 3 times sine t all squared times cosine t outside, which is the differential of what's inside. So I can use the reverse of the chain rule here to integrate this. Okay, so I'm going to take this to the next page and continue. Okay, so as I was saying, this is like the form of the differential of something. The function, the main function is sine something all squared. Inside the function is sine t, and outside the function is the differential of sine t, which is cosine t. Okay, so you can, what I'm going to do is I'm going to sort of rewrite this in another way slightly, just to make it a bit clearer. So I'll write this as 3 times sine t squared times cosine t, and minus 4 times, and this will be sine t to the power 4 times cosine t dt. Now this I can integrate. This is 24. I'm going to have my limits of 0 and pi over 3, sorry. So now this is going to become 3 times, to integrate you add 1 to the power, so you have sine t cubed over 3, and I've got the cosine t already outside, over the new power, which is 3, times the differential of sine t, which is cosine t. And you can see they cancel out. And here I'm going to have to change the power, increase the power by 1. So I'm start off with sine 4. The sine t is going to become sine t to the power 5 because I increase the power by 1. And what will happen is when I divide by the new power and the differential of what's inside the function, which is cosine t, they cancel out. And I've got this pi over 3 and 0. So that's going to give me 24 times, and this is basically sine, this is sine t all cubed, minus 4 over 5 sine t to the power 5. I can leave it like that, it makes it easier. And I've got pi over 3 and 0. This means sine cubed t, that means sine to the power 5t, but leaving it like that is fine. You got 24 times, and this is going to be sine of pi over 3 cubed minus 4 over 5 times the sine of pi over 3 to the power 5. And I've got to take away from that. Now if I put 0 into sine t, it becomes 0, and 0 into sine t, it's going to become 0. So this is going to be minus 0. So now I can work out what this is. Now the sine of pi over 3 is root 3 over 2. So I can just stick this in my calculator, actually, it'll be perfectly fine to do that. I know that sine pi over 3 is the sine of 60, which is root 3 over 2, root 3 over 2 cubed, minus 4/5 root 3 over 2 to the power 5. I'll just put my calculator. Okay, so I end up with 24 times, I'm going to have the sine of root 3 over 2, sorry, pi over 3, and that's to the power of 3 minus 4 over 5 times the sine of pi over 3 to the power of 5, and close the big bracket, and that gives me 6.235 units squared. And you got to find R as a percentage of the circle that is shaded. Okay, so the area of the circle is 9 pi. So the percentage of the logo, which is the whole circle that's shaded, is going to be, so the percentage that's shaded is going to be 6.235 over 9 pi times 100%. That's the area of R divided by the area of the whole circle times 100%, and that gives us, so this divided by 9 pi and then multiplied by 100, which will give us 22.053%, and they want the answer in to 3 significant figures. Okay, 3 significant figures, so that's going to be 22.1. 22.1% is shaded. Okay, there's the answer for question number 5, I think it is. Yes. Okay, so that was a bit of a mission to integrate, but you have to recognize this, that you have something inside the function, and outside of it, it's multiplied by the differential of what's inside the function. So here the main function is something squared. Outside of it is the differential of what's inside the function. Now, I don't think most people show their work in this way, but I like to show it this way to show that basically this part at the end, when you do a reverse of the chain rule, you'll see this part that's multiplied will always cancel out. Okay, just to make sure, I like to do that. So there we have the answer to this question, number 5. From the specimen paper of P4. Other questions which are to do with basically integration. This would be under integration. Part A is really P3 trig identities, but of course it can come in P4. And part B here is basically integration, parametric integration basically. So this would be under the chapter of integration. So it will be in the playlist for integration, which should show up over here. The playlist for this paper, the specimen paper of P4, should show up over here. You can subscribe to the channel by clicking on this icon, and on the top of the page should be a card which should take you to another paper you might be interested in. Thank you very much for listening, and see you soon.